Hi, my name is Takuzo Ganre. I am a former A-level student and I graduated high school with straight A stars, and I'm here to help you do the same, or if not, just make A-level maths a little less challenging for you. So in this video, we'll be learning about functions. More particularly, we'll be learning about definitions and the key terms used in this topic, as well as how to find the range of a function. The syllabus points that we'll focus on are: you should understand the terms function, domain, range, one-to-one function, inverse function, and composition of functions. Identify the range of a given function in simple cases and find the composition of two given functions. So, a function is an expression that defines the relationship between one variable and another. So for example, the equation y equals x plus 2. This is a function because it defines the relationship between the y variable and the x variable. In this topic, however, wherever there's a y, you're going to replace it with f of x. This is how we show that it is a function. So this becomes f of x is equal to x plus 2. Sometimes you may see it being represented as g of x is equal to x plus 2. You can use any letter here. This is how we represent the equation of a function. The domain of a function represents all the input values it can take. They're typically denoted as x values. So usually the input values that a function can take will be restricted, and this is usually in terms of an inequality in x. So for example, x is greater than 2 could be the domain for our function g of x is equal to x plus 2. So that means that this function will only take values of x that are greater than 2. So that's values like 3, 4, 5, and so on. And then the range of a function represents all the output values that are typically denoted as y values. So because we have restricted the x values or the input values that a function can take, it means that the output values that the function will produce will also be restricted. So the range will be based on the domain. A one-to-one function is one that maps every distinct input value to exactly one distinct output value. So for every x value, there will only be one y value if a function is one-to-one. Now let's sketch a graph of an example of a one-to-one function. So we have our curve here. This is a one-to-one function. Say this is x is 1. At this point here, there is only one y value, and that's here. If we come at this x value, there will only be one y value, which is here. Again, if you come here at this x value, you only get one y value. So a one-to-one function means that for every x value, you only have one y value. And we can check if a function is a one-to-one function by using the horizontal line test. To do that, you sketch the graph of the function, and then you're going to draw horizontal lines and check how many times these horizontal lines will intersect with the graph. So the first horizontal line only crosses once, the second one only crosses once, the third one as well crosses once. So if it only crosses once, it means the function is a one-to-one function. If it crosses more than once, the function is not a one-to-one function. For example, if you have this curve here and you use the horizontal line retest, if you draw your horizontal lines, you notice that they're intersecting. This is the first point and this is the second point. Since they're intersecting the graph more than once, it means that this function will not be a one-to-one function. An inverse function is one that reverses the operations of the original function. It is also called an anti-function. So the notation for an inverse function, if your original function is f of x, let's say f of x is x plus 2. To represent an inverse function, we say f to the power minus 1 of x. That shows us that we're defining an inverse function. and this is read as f inverse of x. And since the original function here, we're adding 2 to x, the inverse function will reverse the operations of the original function. So the inverse function in this case will subtract 2. So if the original function is adding 2, it means the inverse function will subtract 2, because the inverse function reverses the operations of the original function. A composite function is a function made out of other functions where its input is the output of another function. Now let's talk about the range of a function. There are questions that will ask you to find the range of a function, and if you want to find the range of a function, you have to be able to sketch the graph of the function that you have been given. So we'll learn how to find the range of a function by doing some example past paper questions. So let's start with number 1. The function f is defined by f of x is equal to 2x squared minus 16x plus 23 for x is less than 3. So this is the domain. This means that this function will only take values of x that are less than 3, that are smaller than 3. Find the range of f. So f of x is equal to 2x squared minus 16x plus 23. So we need to first sketch our graph, and to be able to do that we need the coordinates of the vertex. So we're going to complete the square. Once you complete the square, you get y equals 2x minus 4 squared minus 9, which we'll write as f of x is equal to 2x minus 4 squared minus 9. And then our vertex is 4 minus 9, which is this point over here, and we sketch our curve. Now remember, we've been given the domain x is less than 3. That means we will only take the function starting from x is equal to 3 going this way. That's the part of the graph that we want. So if we do that, this becomes our function f of x. And from here, it's easy to tell the range. So the range are the y values that the function will produce. So we can tell that the range starts at this point going upwards. So if we can find the y value at x is equal to 3, then we can determine the range of this function. To do that, you simply substitute x with 3 in f of x, and you're going to get f of 3 is equal to negative 7. So we now know that at this point y is negative 7, and as we can tell, our curve is increasing going this way, so it means y is greater than negative 7, and that becomes the range of the function. As you can see here, they've written it as f of x is greater than negative 7. You can write it as y is greater than negative 7, or you can also use f of x is greater than negative 7. Now let's move on to number 2. Functions f and g are defined by f of x. This is another way of writing f of x. You can write it this way, or you can write it as f colon x with the arrow, and you write your function. It's the same thing, just slightly different notation. F of x is equal to 3 over 2x plus 1 for x is greater than 0. That's the domain. G of x is 1 over x plus 2 for x is greater than 0. Find the range of f and the range of g. Again, to be able to find the range, we need to sketch the graph. So f of x here is a rational function. So the graph that we need to be able to draw is the graph of y equals 1 over x. If you can sketch the graph of y equals 1 over x, you should be able to sketch the graph of 3 over 2x plus 1. So if we were to sketch the graph of y equals 1 over x, looks like this. This is what it looks like. But now notice that we have a 3 here, we have a 2 here, we have a 1. So these are now transformations. If you add a plus 1 to the graph of 1 over x, this plus 1 represents a shift or a translation in the x-axis by minus 1 unit. So that would look something like this. That would mean this line would become negative 1, and then your y-axis would be somewhere here. This would be the y-axis, because we've now shifted the graph by -1 unit. And then putting a 3 on top, that's just stretching the graph in the y-axis, and a 2 is a stretch in the x-axis. Okay, so if we are to draw our graph here, we know that this 1 represents a shift in the x-axis by -1 unit. So this would be -1, and then would sketch our graph. The 3 is a stretch in the y and the 2 is a stretch in the x. Since this is not an exact sketch, they will not affect what the graph looks like. So our graph will look something like this, but notice that the domain is x is greater than 0. So I'll draw the region that we want in red. So we only want this part. This part represents f of x. Okay, and as you can tell here, this line f of x, it's approaching the x-axis, but the x-axis is an asymptote to the graph of f of x, and so they will never touch. So it means that this graph f of x will always be greater than 0. It's approaching 0, but it will not reach 0. And then we need to find what y is when x is 0. So we need to find this value, and to do that we can simply substitute x with 0 in f of x. So that will be f of 0 is equal to 3 over 2 times 0 plus 1. This gives us f of 0 is equal to 3. So here we know that it's 3. So we know that f of x will always be less than 3, and it will always be greater than 0. So we can write this as one continuous inequality. So that's f of x is between 0 and 3. And that's the range of y values that this graph will give us. So starting from this point up to 3. Those are all the y values we can get from the graph of f of x. As you can tell here, the range of f of x is between 0 and 3. Now let's move on to the range of g. G of x is equal to 1 over x plus 2 for x is greater than 0. So again, the graph of y equals 1 over x looks like this. But notice now we now have a plus 2. The plus 2 means that we are translating our graph by 2 units in the y-axis. So it's going to move upwards by 2 units. So if we're to erase this graph and sketch it, it should look like this. If we lay 1, 2, we're going to draw a dotted line here. And now you're drawing the exact same graph, but now it has been shifted up by 2 units. And remember that we don't need to draw this side of the graph because x is greater than 0. So we only want when x is greater than 0. As you can tell here that the line y equals 2 is an asymptote to the graph of g of x. So the graph is approaching y equals 2. It will never reach y equals 2. So that means that g of x is greater than 2. On this side, the y-axis is an asymptote to the graph of g of x, so it means that the graph will never meet the y-axis. So this means that the values of g of x, as it increases, they will continue to get higher and higher. So the y values will be bigger and bigger and bigger, and they will go up to infinity. So in other words, we're saying that g of x will go up to infinity. G of x is less than infinity. So again, we can write this as saying that g of x is between 2 and infinity. But we don't need to write this infinity part. We can just write it as g of x is greater than 2, and that would be our final answer. Let's move on to number 3. The function f is defined by f of x is equal to x minus 2 squared minus 4 for x is greater than or equal to 2. x is greater than or equal to 2 is our domain. The question asks us to state the range of f. Again, we have to sketch the graph of f of x. To do that, in this case, we're already given the completed square form, so we can just read out the coordinates of the vertex, which are 2, -4, and we'll use that to plot our graph. And then from here, this is 2, -4, that's our vertex, and we have sketched our graph. And our domain is x is greater than or equal to 2, so that means we want the graph on the right hand side, and it will look like this, going to the right. That's our graph. And since we already know the y value here at -4, we can pretty much tell what our range is. Our graph is increasing, going up, so you can tell that our y values are y is greater than -4, and that will be our range. But also notice that in the domain they've used greater than or equal to sign, so that means in our answer we should have an or equal to sign. And we can also write this as f of x is greater than or equal to -4, and that would be the final answer. That's all for today's video. Thank you for watching. If you want access to this PDF, I've left a link down below in the description, and you can also access more resources on my website, CIE A Level Maths 9709.com. The link is also down below in the description. Thank you.